Awesome. Thank you, Mike. Uh, can I get permission to share my screen? I do not have the permission right now, but while we wait, I'll talk a little about myself. Mike obviously sort of highlighted what our, oh great, now I can do it. Mike highlighted what our group is about. I'm so sorry. Mike sort of highlighted about what our group is about. But yeah, I'm a data scientist at the NFL League office. I've been working there since February. Today I'm going to be talking about using betting line data to estimate the magnitude of travel, rest, and home advantages in the NFL today. My Twitter is @DataWithBliss. If you want to tweet a question or something about the talk, or just send me a funny meme, feel free to do so. I appreciate it all. Yeah, first I'd like to say I'm thankful for being here. I'm really excited to be here. I'd like to thank everybody on the panel, everybody who organized. I want to thank Mike because he helped me a lot with this presentation as well as getting me involved. So with that, I'll just jump right into it. The goal of the research that I'm presenting today, we were attempting to figure out what is the magnitude of home field advantage? What is the magnitude of travel advantage? What's the magnitude of rest advantage? How does that affect actual outcomes of games? How does playing on a Monday night compared to another team playing on a Sunday night, how does that affect the outcome? How does playing at home affect the outcome? All of this is incredibly important to us as we put together a schedule. We have a scheduling group, and it's a very difficult process. And although we like to have, we're ultimately an entertainment industry, we also want to make sure we're fair to the teams. If we wanted to optimize for entertainment, we just have Cowboys and Kansas City Chiefs playing every Monday, Thursday, and Sunday. But we do have to have some evenness of the schedule. It'd be unfair if playing on these days is a disadvantage, and these teams are constantly being given this disadvantage. So we have to make sure that rest advantages are distributed equally. Travel, home advantages, teams have to play in London sometimes. We have to make sure that's all even. All this also applies to the postseason format. As I'm sure many of you know, in 2020, we have a different postseason format than we normally do. We now have 7 teams in the playoffs, and one less team has a bye. Before, 2 teams would have a bye per conference. Now only 1 team has a bye per conference, and that's significant. And we have to think about, okay, now there's less. A team doesn't have a pretty big rest advantage. You have a full week off. That's pretty big. A team doesn't have that. What does that do to the postseason? And finally, this all can tie into rules proposals. There's a lot of rule proposals that we as the data team in the league office, we look at, and some of them tie into, if you're the home team, you get X, you're the visiting team, you get X. We got to make sure that we know what advantages already exist when we're applying these rules. So the process that we kind of go through, I use sports betting data, and I'm going to explain why sports betting data is significant in what we use in a sec, and a Gibbs sampling model. And what we attempt to do is we try to parse these magnitudes out of the betting lines, try to parse them out of the betting line probabilities to figure out what exactly they are. So we know that a betting line will be based on how good the teams are, and then these several other advantages. We have to figure out, okay, what part of the betting line goes to how good these teams are, what part of the betting line goes to this advantage, what part of the betting line goes to this advantage. And one other thing I would like to say, a lot of this work is built on a paper, Randomness in Sport, by Matthews, Baumer, and Mike Lopez. So I would highly recommend you check that out, especially if you're interested in what I talk about today. So yeah. So I'll first explain why are we using betting line data, because it might seem a little bit random, like why betting line data? Well, the reason we like betting line data is it's incredibly accurate. So what we have here is we have the y-axis is the observed probability, the observed win probability. The x-axis is the betting line implied probability. Each dot represents a cluster of games. So we take a cluster of games where the betting line probability, for example, is around like 50% or maybe 45%. We take this cluster and we compare that probability to the actual win percentage of games that are sort of within that cluster. And we see how does that match up. So anything on the line means it's a perfect measurement. And as you can see, outside of maybe a few dots on the ends, a lot of these dots are right on the line. That tells us that these betting lines are pretty accurate. They're telling us that when they say it's about a 20% chance of winning, it typically means it's 20% of the teams actually win. And I guess another thing I'd like to note here is the bigger the dot, the bigger the cluster of games. So although we have a few dots on the two ends that are off the line, they're smaller. I think the dot closest to 0%, I think, is literally 6 games, and none of them happen to be victories. And this one, the one in the upper right-hand corner, might be 30 games. So we really feel good about this betting line data, and we really feel good if we're trying to estimate information from it. We feel like this is a very good source to estimate information. All right, so back to what we're really interested in here. We want to figure out, how do these betting markets perceive home advantage, rest advantage, and travel advantage? We want to see, do the betting markets perceive the same they do now that they did 10 years ago? Is it totally new? Is it totally, does it change per week, for example? Maybe a buy in week 3 doesn't matter as much as a buy in week 13. Maybe if you travel later in the season, maybe that also might have an effect. We're interested. Is this, when are buys most significant? Are they most significant at different times? There's a lot of different things to think about. And finally, we're going to look at and say, are some teams benefiting or not benefiting from these advantages? Is it significant? What's going on there? So I'm going to go through these. I don't have any slides on home advantage. I think that is pretty intuitive. The home advantage simply is defined as, if you're playing at home, you have home advantage. If, for example, the Jaguars like to play in London a lot, the Jaguars playing in London, they do not have home advantage. That's a neutral site. Bills playing in Toronto, that's neutral site. But if you are playing on your own home field, that's home advantage, and that's our definition. So I'm not going to get too deep into that, but I will get into travel and rest advantage. Although we know that travel and rest advantages exist, or we think they might exist, how would you actually define a team with a travel advantage? So we thought about different ways to think about that. Is it an issue of time zones? Maybe if teams are playing on different time zones, like you're not, one team is used to playing at 1 o'clock, one team feels like they're playing at 12 o'clock. Is that an advantage? We found it was insignificant compared to other variables. Another thing that it's talked about a lot is, what if a Pacific time team, like a West Coast team, like Raiders, 49ers, Rams, Chargers, they have to go to the East Coast and they're playing at that 1 p.m. Sunday window? Is that a big disadvantage? Are they unable to, they feel like they're playing at 10 a.m. and the team they're playing feels like playing at 1 p.m. Is that a big advantage? And again, it was insignificant when we looked at some other variables. We also thought, maybe the reverse. Maybe if you're an East Coast team and you're going to the West Coast and you're playing at night, maybe that's a big disadvantage. Again, it wasn't that big. Part of the issue with this in particular was there was a very small sample size. Most of our teams are on the East Coast, so it's not as likely. And there's only three primetime windows a week typically. So you're not. And West Coast teams tend to play other West Coast teams because of the way the divisions are structured. So it doesn't happen as often, but that was insignificant. The one thing that really stood out as significant is travel distance, just pure miles, how far you went from one side of the country to another. So right here we have a chart. We're thinking about the distance defined by travel miles. X-axis and Y-axis are the same. That's the real distance in miles. Each dot represents a number of games at that given travel distance. Bigger the dot, more games. So I highlight 4 games here. I chose to choose the New York Giants. I mean, we are at UConn, and that's, I guess, the closest team. I guess the Jets are a tie. And I imagine a lot of our West Coast friends might still be asleep because it's early. So I decided to choose New York Giants. Just everyone knows that. So I highlighted 4 games here. So the Giants playing New York, the Giants playing Philadelphia, the Giants playing LA, and the Giants playing San Francisco. My intuitive thought was, okay, if the Giants are playing the Jets, they're literally not leaving. They're staying in their own home bed. They're playing at their own stadium. Just maybe they're playing in a visitor locker room, maybe they're not. The difference between that and actually having to take an hour and a half drive to Philadelphia, that's pretty huge in my opinion. Like you're going from nothing to something. But when you think about LA versus San Francisco, I would think that's probably about the same. I grew up in California and I live in New York now. I didn't even know that San Francisco was further away than LA. I thought LA was further. So I didn't even know that there was a difference. To me, I think they're both pretty long flights. I don't know if it really matters. So I created this slide to sort of just highlight what I'm talking about. I mean, the difference between Philadelphia to New York is 85 miles, whereas San Francisco and LA from New York, it's 99 miles. So if we just use straight travel distance like that, we're suggesting that the difference between New York and Philadelphia compared to New York and New York, that is a smaller difference than New York going to one of 2 cities in California, which are a 5-hour flight away. We knew that didn't really make sense. So what we did was we thought, okay, we're going to allow our model, in the modeling stage, I'm going to touch on this a little bit more. We're going to allow our model to transform the distance to make it so at the tail end, it really doesn't matter whether you're another 100 miles away, but at the very start, it's a huge difference. Each mile really counts. Sort of the thought we wanted, and for those who love calculus, I don't know how many are out there. I mean, maybe there are a decent amount at a sports analytics conference, but for those who love calculus, we wanted to have a negative derivative. We wanted it to the curve to slow down, to flatten out as miles increased. So we let the model sort of find what was best. We tried a few functions. We tried exponential, we tanh, we tried some trigonometric functions. The thing that really worked the best we found was an nth root function. I mean, we let the model determine n, and the answer is about 1/5. But anyway, the value here, and you can see in the graph. I mean, New York versus New York is right down there, and then a big jump to Philadelphia, and then LA and San Francisco right next to each other. It works out a lot better. Now the advantage is a lot bigger between Philadelphia. The travel advantage for Philadelphia compared to the New York Jets is a lot bigger than the 49ers compared to the Rams, which again, I'm still surprised that there was that the 49ers are actually, San Francisco's further away from LA. So we went ahead and made that fix, and that's how we define travel distance in our data. Obviously, we have the schedule, so we know where teams are playing, and this is observed data. This is data that we are aware of. So now that we have a way to sort of quantify our observed travel data, now we have to think about rest. So right here we have a histogram. The left-hand side of the histogram will have situations where the away team has more days of rest than the home team. The right side will be situations in which the home team has more days of rest than the away team. And right at 0, it's even rest. And these differences can occur because of a Monday night football game or a Thursday night football game or a bye week. Something like that has happened where they're not playing on the same day, but then they meet on the same day. So 2/3 of games we're going to call even rest. They have the exact same number of days of rest. It doesn't make a difference whether they both have the same sort of rest advantage. No team had more rest than another. We're going to define 1 to 4 days as short rest. This is typically a Monday night, a Thursday night, maybe even a Saturday game. Something happened and one team has 4 days, one team has 2. I mean, it's typically 1 or 3, I think, which correspond to Thursday and Monday night football. and that's what we define as a short rest advantage. Finally, we have the bye advantage, and that's a team had an entire week off and you're meeting. I mean, one team played 14 days ago, one team played 7 days ago, or this could be 13 or 15, depending on how the prime time windows line up. But that's what we call bye advantage. And obviously, this is, again, something we have a schedule. We know what dates teams played, so this is observed. We know what advantages teams had, and now we just have to measure the significance. One last note about this slide that I'm going to mention. When two teams are coming off byes, but one team maybe played on a Monday, so one team played like 13 days ago, one team played 14 days ago, we just put that into even rest category, simply because I don't think that after a certain point, if you have 13 days versus 14 days, that one day probably doesn't matter. A lot of the players will have a few days off during that week anyway, so that is just an even rest. All right, so now that we've defined what our observed data, how we're quantifying our observed data, now we got to get into some math. This is a lot of math. I thank everybody for waking up early on a Saturday and choosing to look at this much math. But I'll try to get through it, and we'll get and hopefully you'll understand. So the first, what I have here is an equation, a bunch of definitions. I'm going to do something. I'm going to highlight what is observed and what is estimated, what we already know from the schedule and what we're trying to figure out. So the red is estimated. The red is our quantities we're going to learn from our model. The black is stuff that we already know because we have the schedule or the betting line data for our dependent variable. So I'm going to go through and explain each of these set of terms one by one. I don't want to get too into the weeds of this. I feel the results will probably be a little bit interesting, but I also want to make sure everybody understands how we got them. So the first term I'm going to highlight here, this is our dependent variable. This is on the left-hand side of the equation. This is our y. This is the variable that we're using to sort of drive the model. So what we have here is the betting line implied probability that team I will beat team J during season S in week K. So for example, let's say the Raiders played the Chiefs week 5 last year. It would be for that probability would be the probability in season equals 2019, week equals 5, that team I, the Chiefs, will beat team J, the Raiders. We notice that it's not per season. Each week we have a different betting line probability, and that's true throughout, and that's an important distinction that we're paying attention to. That's because for a lot of reasons, I mean, there are teams that start out hot and maybe have some injuries and don't finish as well, and there are teams that sort of get a second win late in the season. So we got to make sure that we're taking into account that teams change week to week. Maybe there's a quarterback change. Maybe injuries is a big one too. Maybe there's a coach gets fired. There's a lot of things that could happen week to week. So we got to make sure that we have a different probability each week. The next two terms, these are I'm going to highlight they're theta for those of you who like Greek symbols. The theta terms, that is the team strength of team I and team J during season S and week K. And again, team strengths change all the time. For example, our model felt when Patrick Mahomes was injured last year, the team strength was lower than when he was healthy. And that's probably true with a lot of teams' quarterbacks, but that's the most extreme example I can think of. So we have the team strength of team I during season S and week K. So it could be the Chiefs 2019 week 5, and then the team strength of team J during season S and week K, the Raiders 2019 week 5. And we're subtracting them. We're figuring out what is the difference between the two team strengths. They could be equal. One could be better than the other. This will sort of account for the team strength part of the model. Again, as I sort of said from the beginning, we're not necessarily interested in this. This is just something we know betting lines take into account, and we have to make sure that we're taking them into account in order to parse out the information we actually are interested in. Okay. So the next term we have here is our home advantage term. we have both an intercept, which is alpha H, and a trend term, which is beta H. Alpha will be constant, and beta will be a trend. Actually, let me start by explaining this last term a little bit. This is probably the most important part. This is the home advantage. This is observed. So this will be equal to 1 if the team is actually playing at home, and 0 if it's a neutral site. So this alpha term that we're going to be estimating will provide a value for a constant home advantage that's been true 2006 to 2019. That's our data set. That'll be true the entire time. This beta term, because we found that home advantage actually is changing each season, will account for how it's changing per season. So if S is equal to 2006, this will be 0. If S is equal to 2019, it'll be pushed all the way to it'll be adjusted based on the fact that it's 2019. That's what we were able to find from for home advantage. The next is travel. And again, this alpha term is really what we're interested in, alpha T. That is multiplied by, as I described in the previous slide, the observed travel distance. The travel distance will be the distance from the visiting team, from Team J to the game site, minus Team I to the game site. So let's say if Team I is playing at home, like actual home, that'll be 0. So it'll be just the miles Team J is traveling. Let's say if they're meeting in London, that number could even be negative if Team I might be designated as the home team, but Team I, that could be negative if Team I actually, like, I remember the Raiders hosted the Dolphins in London. That was technically a home team for the Raiders. That doesn't actually mean that the Raiders had home advantage, and then nor did they have travel advantage. And then this exponent here, that's how we got the 1/5. That is an estimate of what the transformation should be. Again, we're not necessarily interested in that, but we know we need to have it to figure it out, that gamma right there in the exponent. That's just something we need to know. And finally, I'm almost done with the math, I promise. We have our rest terms. So this rest term, alpha short rest, that's what we're interested in. This is the observed short rest. So if Team I has short rest advantage, it'll be equal to 1. If it's even rest, it'll be equal to 0. So this entire term will just disappear. If Team I has a short rest disadvantage, then this will be -1. So this will work in Team J's favor. This term works the exact same way except for with bi-rest. So that these terms just account for the rest as I described. I hope that you guys were able to follow that. I could get more deep into the math if people wish during the question session, but this is all I have for math. So for those of you who fell asleep, please wake back up and we'll start to get to the results. So although we aren't interested necessarily in team strength, one way we can validate our model, make sure this model makes sense, is see what teams are what teams are doing, what teams are the best in terms of team strength. Throughout our data set. So the best team for a given season week from 2006 to 2019 are the New England Patriots in 2007. They were the 16-0 team during the regular season. So it's no surprise that they're seen as the best team from 2006 to 2019, the entirety of our data set. The worst team was the Dolphins last year. And as some of you guys might remember, the Dolphins started out 0-8 or 0-9. They lost a bunch of games by like double digits. I remember the first game, I think they lost 49-10 to the Baltimore Ravens. They just got absolutely killed. I don't know a better way to say it. But another team also that was sort of in the mix for being the worst team were the Jacksonville Jaguars of 2013 during Week 8, which again maybe isn't a team that's memorable, but they lost every game by an average of 21 points going into Week 8. And yeah, and that's another thing that I want to sort of note about the Dolphins too. They started out very poorly. They actually finished the season with 5 wins. They weren't an awful, historically bad team, but based on how they played at the beginning of the season, this was able to pick up. Okay, this was a bad team from the get-go. So now what I'm going to do is I'm going to plot each of the team strengths by week. And this is the 2019 season. I know we're in the 2020 season, so maybe we don't remember all the storylines and how teams went. It was all about a year ago when during the season. But I'm just going to sort of recap. These are plots of the 4 AFC East teams. As a lot of us remember, the Patriots started out really well, but then sort of towards the end of the season, they tailed off. The Dolphins, as I was just sort of saying in the previous slide, they started off very poorly, but they ended the season not on a bad note. The Jets, they also had a sort of a dip in the middle of the season. Then they ended the season 7-9. So the model is able to pick up on team improvement. The team doesn't have to be constant throughout. These are all the divisions, 2019 by week. And again, maybe we don't remember the storylines, but I'll just highlight a few things that were interesting. As I noted, the Chiefs started out really strong. Patrick Mahomes gets injured, and then they have a few dots where their team strength sort of dips. Yeah, maybe to make this, I should have made it more clear on the last slide. The y-axis here are point spread added, sort of point differential, expected point differential against an average team. So the higher you are, the better. The lower you are, the worse. And the x-axis is weak. But as the Chiefs started out as a very strong team in terms of their team strength, Patrick Mahomes unfortunately gets injured. They go down. He comes back, and then they're a top team again. Another team I'd like to highlight are the Detroit Lions in this gray and dark blue in the NFC North. They were a pretty good team. Then Stafford gets injured. I think they were 4-4 or 5-4, something like that. Then they go completely downhill simply because they lost their quarterback. And another division I like to highlight is the NFC East. We see 2 teams, Philadelphia and Dallas at the top, 2 teams, New York and Washington in the bottom. Sort of what we'd expect. And I guess one more, the NFC West. We have 3 teams that are very good. The Cardinals weren't as good last year. So it's interesting. We can talk about a bunch of these divisions, and you can sort of see how teams change throughout the season, and certain things might have affected their perceived team strength from the betting market. All right, now let's talk about the results that we as the league were actually interested in. What does the model actually think about in terms of rest, in terms of home advantage, in terms of travel advantage? So short rest is worth about 0.36 points. That's the estimate of the Gibbs sampling model. Buy rest about 0.67. Those both seem pretty reasonable to me. So they're both about half a point, but buy rest is a little bit more. And again, point spread can kind of be thought of as just expected margin of victory. So just these sort of help by about half a point. They sort of help in maybe a toss-up game. That's sort of what this is implying. Home advantage is about 2.15 points. The people probably are a little bit confused by that because typically you think of home advantage in the NFL, it's 2.5 to 3 points. However, if we add in the travel advantage, and most of the time they're separated out, on average, an NFL team travels about 500 miles. So if you add about 0.69, that's the average travel, you get right in the 2.7, 2.8 range, which is typically what most of us would expect for home advantage. But this is really interesting in the sense that when base home advantage with no like New York playing at New York, we estimate it more closer to 2 points than maybe 3 points, as might be the case when you're actually traveling outside of your stadium. So these are one advantage of the Gibbs sampling model. It's the sampling model, so we get various estimates. We can get a distribution of what our answers are. We can look at the magnitudes here, as we sort of saw on the previous slide. Short rest and by rest are certainly less than the other magnitudes that we're seeing here. One thing that I think is interesting is we noticed that the distribution, the estimate for home advantage with 0 miles is really flat. That is partially because there aren't that many games with 0 miles. It's only New York at New York. We'll start to get some now that the 2 LA teams share a stadium, but for the most part, that's the only time we really see those type of games. And the home advantage with 500 miles, that's the skinniest, simply because that's where we see the most amount of games, about 500 miles. And 2,000 miles a little bit is in between the two, because we see that more often than 0 miles, but it's still not necessarily a common occurrence. So we now want to think, okay, are these changing over time? And as I sort of highlighted in the modeling stage, we found that short and by rest actually aren't changing that much over time. We thought maybe by season we didn't have a reason to think by season they would change, but by weeks we thought maybe a week 4 bye is way more important than a week 15 bye. From what we were able to estimate from the betting markets, we haven't really found that to be the case. There are different, part of it is we have a smaller sample size. That, I mean, a team only gets 1 bye per season. Maybe they're playing another team with a bye, but typically we might only see about 30 or so bye rests per season, which isn't that many. So maybe with more data, we'll start to pick something up, but we haven't found something that would suggest that there's a difference by week. I mean, we have enough data to pick up it in general. Just the issue is, if we're dividing it by week, then we're really limiting our space maybe to like 10 or so, not that many per season, not that many in the total data set. So that's why that's part of the reason maybe we didn't find anything, but so far we haven't seen it. The home advantage we found actually has been dropping each season by about 0.07 points. The 0.215 that we showed here, that's the average actually across all seasons. In 2006, it was about half a point more. In 2019, it's about half a point less. So from 2006 to 2019, it's almost dropped a full point, which is crazy. It's a lot. And I'm going to get into maybe some reasons why in the next slide. But I'll just also note that travel advantage we haven't really found has changed. So it's not that teams are getting better, particularly at travel. It's something else relating to home advantage that, or at least that's what the betting markets are perceiving it. The estimate suggests that it's something else related to home advantage outside of travel. So I just wanted to highlight what how home advantage is changing. Right here we have travel to the average, which is around 500 miles. And as you can see in 2006, it's about 3.5. And this is if we use each season as the individual home advantage each season. This line is a best fit linear trend line to it. In 2006, it's about 3.5. In 2019, it was under 2.5. And it's a very clear linear trend. I don't think there's really a doubt about it when we look at it this way. Home advantage is decreasing. And we thought about a lot of things. We thought maybe it had to do with teams are traveling better, but we didn't see it in travel advantage. Maybe teams are getting better breaks on the road. Maybe crowd noise. We weren't entirely sure. But we investigated sort of some key statistics that we can measure in general about the team. And we looked at whether or not they have been changing for home and visiting teams or they're staying the same. So, I mean, I'm about to show probably the most key statistic in determining the outcome of an NFL game, points scored. If you score more points than your opponent, you typically win. You always win, actually. I misspoke there. You always win. So the we looked at points scored by season, and we look at 2006, and we compare it to 2019. This gap is shrinking. Both teams are maybe scoring a little bit more points, but the visiting team, the home team is kind of flattening out. The visiting team is catching up. So yeah, maybe to speak more to the graph, I maybe jump right into it. Each dot here represents a season and a week, and the y-axis is points per game. So, for example, in 2006 week 2, the home team on average scored around 26 points per game. And these trend lines, they're sort of best fit lines, they're average lines, they're smoother lines, just trying to pick up on average, what does it kind of look like? And this line that's sort of the average visitor score when we go across season and weeks, it's meeting up with this line that's the average home score going across season and weeks, and it's about the same by the end. And it's interesting. So that's kind of a pretty easy way to think about it. Another thing we thought about is penalties, or maybe penalties changing. And there are some penalties, such as offensive holding, and this graph works exactly the same. Each dot represents a season and week, and the average for that season and week in terms of fouls committed per game. And the x-axis is season, week, y-axis is the fouls. So we thought maybe penalties and some sort of in-play penalties, such as offensive holding, defensive holding, these are pretty common penalties. These lines look pretty much the same. The difference between them seem the same. There isn't really a change like, oh, now visiting teams aren't committing offensive holding or something like that. That's not really the case during these in-game penalties or in-play penalties. But the pre-snap penalties, we're definitely seeing visiting teams performing better, doing better, or maybe even just getting the home team to commit them more often. So we look at neutral zone infraction. We see this big gap between neutral zone infraction of the home team and the visiting team. Visiting teams are committing it a lot more often. But by 2019, by the end of our data set, it's about the same. And same with delay of game. And these are these are penalties that maybe have to do with cadence and maybe have to do with different, the quarterbacks trying to get the defenders to jump, or crowd noise, or something like that. The visiting teams are catching up to the home teams in terms of that, which is really interesting. So that's kind of what we are attributing to now. I mean, there's probably a bunch of explanations on why home advantage is shrinking. But these are the two ones that I really wanted to highlight, because they're clear and they make a whole lot of sense. All right, so this is my summary. Home advantage is nearly down a full point since 2006, which is pretty incredible. Fine and short rest are worth about 0.67, 0.36 points, so they're not nothing. So if a team wants to complain that maybe they had to play primetime windows, we can have that discussion simply because now we know, okay, this is how much they're worth. This is maybe how it had, like the effect in general it might have had on your team across schedules. We can actually sort of discuss that with numbers rather than sort of arguing, oh, this is really important, this is not really important. We actually know a numeric way to measure how important it's been. And finally, travel distance is a lot more significant than time zone. So that's kind of what we found. The next steps that we're definitely going to be looking at, I'm guessing I might get some questions about this, maybe not, but the next steps is, well, obviously we know we're in a pretty unique season. We're going to have the opportunity to measure maybe value of fans. How much do crowds affect outcome of games? Unfortunately, I tried. I wanted to have something interesting for this presentation. Unfortunately, it's really difficult, as a lot of you statisticians and data scientists will know, to make a inclusive point using only 63 games. I guess there's 64 considering the Thursday night game, but only using 64 games, 64 data points, where we might have unusual crowd conditions. So right now we don't really have a strong or a good answer on why that might be the case. But hopefully in the 2020 off season, or maybe mid-season, once we just have a few more games under our belt, we can go ahead and make a conclusion and find something interesting in regards to that. So with that, I want to say thank you. Thanks for listening, and I'm more than happy to answer any questions. So are there no questions, or am I supposed to read them somewhere?
Greg will be your chair. Let me. Well, there's some question in the Q&A window. Would you like to address them?
Sure. Let me see if I can pull that up. I can't see it. Oh, this is annoying. I can't see it unless I think I can't see it unless I stop sharing my screen.
Okay. Let me. Greg will relay the question to you.
Okay. That sounds good.
Greg.
Okay. Here, I was muted. Our internet decided to stop working halfway through the talk, and so I got kicked out, and I am back now. My name's Greg Matthews. I just want to introduce myself really quickly. I'm actually a UConn alum. I did my PhD there. I actually had Dr. Yan was my professor for mathematical statistics, both for first and second semester. And now I'm an associate professor of statistics at Loyola University of Chicago, and I live in the best city in America, Chicago. So let's start with some questions. I'm going to go first because I have that power. So Tom, I was in those plots you showed about penalties. It looks like there's a big increase in around 2012 or 2013. If you look at delay of game or defensive holding and neutral zone infraction, it looks like there's this increase is happening sort of at the same time around 2012, 2013. Was there some league-wide was there some rules changes that happened, or was there some mandate from the league to call these penalties more around that time? Can you talk about that a little?
So it's a combination. Yes. So to answer your question, yes, but it's a combination of a few things. One, neutral zone infractions in particular. We're calling more neutral zone infractions in the league, partially for quarterback safety. I don't know if you guys maybe remember in 2010, you can picture Aaron Rodgers drawing players offside and throwing it deep. That's not as often anymore. They're blown dead typically, unless so defenders won't get a free shot at the quarterback. Defensive holding, I think there's just been more of a sort of focus on making sure those are called correctly. So that's part of the reason why. But another big reason is we're seeing a lot more plays per game. The league used to be more of a running league. Now it's more of a passing league, which is good in my opinion. But with more passing, there's going to be more incomplete passes, more time stoppages, and also more scoring. So there's going to be more plays per game. And teams are also snapping it with more time on the play clock. They're not just trying to play possession football. So with more plays, you're going to get more penalties because there's just more opportunities to commit them.
Okay. Here's a question from. I'm trying to do these in order. They're coming up in a strange order here. Let's see if we can go back to find the earliest one. All right. Here's a question from Zach Binkley. Hi. How are you considering nutritional science into this? Individual nutrition plays a role in recovery along with travel. Is that something you're considering at all?
Hi. So that is not something we're considering. One thing about that is, I guess the way we might consider that is we don't have measurements of how good or how teams are doing nutritional science. We could possibly maybe have a team-specific rest advantage. Maybe some teams, because they are good at nutritional science, they have some sort of bonus rest advantage or some less rest advantage. Maybe they're not good at nutritional science. The issue with that is that just creates very small sample sizes, and it's impossible to know, like, does this team have the same nutritional scientists from 5 years ago? Are they changing? I mean, we actually, maybe at the league we have that written down somewhere, but it would really shrink the sample sizes. Most teams will only have 4, 5 max sort of rest advantages or disadvantages per season. It really wouldn't make sense for us to even, I mean, using just rest across all seasons, I think we have enough, but to have to shrink it specific to team, I don't think that would really work. And yeah, we don't have a measurement of teams' strength at nutritional science, and maybe if we did, we could incorporate it.
Thank you. All right, this is a question from Trevor Anderson. He refers to you as Mr. Bliss, which means you're old now. Do you think that postponing of games due to COVID tests, for example, the Bills game on Tuesday now, can affect the players? And do you think that playing on an abnormal game day will affect the players at all?
Yeah, those are great questions. So, I mean, I don't know. I'm not sure about conditions specific to COVID. We haven't really analyzed this season. But in terms of the fact, just a team playing on a Tuesday, absolutely. I mean, we found that rest advantages do matter. And I believe the Bills are playing on Tuesday and they're playing the Chiefs on Saturday or Sunday the following week. That is a big, that's a disadvantage to the Bills. And who are the Bills? The Bills are playing the Titans. The Titans haven't played in a few weeks. They had a bye advantage. That also is a disadvantage to the Bills. So absolutely, playing on those abnormal times will affect in terms of rest advantage. We don't have that much data in terms of, like, does Tuesday night football matter? Just because I think there's only been one Tuesday night game since within our data set. I think it was one in 2010, like Eagles Vikings. But that because they're so uncommon, I can't really speak to Tuesday night in specific. But I do think that there are going to be some rest advantages and disadvantages felt by the Bills, Chiefs, and Titans.
Thank you. This is another question from Alexander Harriman, and this is an undergraduate at Clemson University, and I hear they have a football team down there. He's wondering. I was wondering how you decided on the style of model you chose for your study.
Yeah, I actually have a slide in the appendix about that. So I didn't want to get too into it during the presentation. It's a bit mathy, but we wanted to use the Gibbs sampling model for sort of 3 key reasons. One, it allows for week-to-week, season-to-season interaction of team strength. So those data scientists out there, I mean, even think about linear regression, you're supposed to have independence of each sort of row. Each row is not supposed to affect each other. However, in our case, we know that the 2019 Week 1 Chiefs have an interaction with the 2019 Week 2 Chiefs, which have an interaction with the 2019 Week 3 Chiefs, and also the 2018 Chiefs in general have an interaction with the 2019 Chiefs. You're not putting on a totally different football team with new coaches and new players each week. There's interaction, although they're not exactly the same. So that's one reason. Another reason is we have a bunch of probability distributions for each variable. They have different probability distributions. I can get deeper into that if people want, but they're joint conditional probability distributions. I don't want to do a full lecture on that. I'm maybe not even the most equipped person to do that, but because of that, that's another advantage. And the general process of this is it's like coordinate ascent, coordinate descent, expectation maximization, if you happen to know any of those. We're sort of allowing we're sampling from one variable, then learning from it, and sampling from another, and then learning from it. And the variables are sort of working together and adjusting together. And for that reason, it worked out really well, better than like a simple linear model or even a tree-based model.
Thank you. This is a really interesting question. This is from Celine Unal. And they say, I'm wondering about the transformation of the difference in days of rest into a categorical variable. In soccer, there is this idea that too much rest is a problem, as no training can truly replace competitive games. So I think the question here is about how I believe the way you've included your rest variable, and you're not. I don't think you'll allow for the rest to ever get worse. In terms of, it'll always be like the more rest you get, the better off you are. And if you converted it to a categorical variable, you would be allowing for maybe a point where after that it's too much rest. Do you want to talk about that a little bit?
Yeah. So I mean, so maybe the rest is treated as a categorical variable.
It is. Okay.
I mean, and part of it was I didn't tell the model, okay, this has to be positive, this has to be negative. I let the model figure it out, and the model found that it was positive. I absolutely would agree, if you have too much rest, that probably is a disadvantage, and I'm sure that exists in football. However, during the regular season, there isn't a situation where it's more than 7 or 8 days. So because of that, we feel that it probably wouldn't be an issue. Based on our measurements, and our estimates, we found that that's not the case. I agree that in principle that probably is the case at a certain point, but we don't really have data where that would suggest that.
Okay. Oh, there was follow-ups that I didn't. Well, let me ask this other question. This is from Mike Templeton. How did your data take into account when teams that stayed out in West Coast, if they played 2 weeks, played the Rams and the Chargers back-to-back, and they stayed out on the West Coast? So it might look like there's travel, but there wasn't actually. Do you account for that?
That's a really good point. No, we did not account for that. We would ideally, we would like to. It just would be. It was we don't have that data present. Maybe we should, but we couldn't figure out. It would have been too much. It would have just been a bunch of Googling and figuring out what actual team schedules are, and it just didn't really seem to be worth the time of doing that. It's not particularly common. You'd have to play 2 visiting teams sort of back to back that are nearby each other. It's a good question, though.
Okay. I think I butchered Celine's question. I'm going to try to ask this again because I didn't read the rest of this. So the follow-up was, do you think information is lost by transforming the rest days first into a difference, then into a categorical variable? So maybe rest days being 3 versus 6 is different than 12 versus 15, or it might even be that rest days being 6 versus I think that's a different question than I was originally asking. Does that make sense, Tom?
Yeah, that does make sense. That's a really good question. So we did try it linearly, difference of rest days linearly, but that is a good point. I mean, maybe it's almost like it's not like a linear. Maybe difference isn't the best way to think about it. That's definitely something we can explore. So I really like that idea. But we did try difference linearly. The difficulty, though, unfortunately, is in terms of doing like 3 versus 6 might be different than like 4 versus 7. The difficulty is the sample size is a little bit smaller. The sample size is not that big to begin with. And that, again, would sort of be an issue where it would be shrinking the sample size. But I would agree in general that could have an effect different. And I think that's a really good point.
Thank you, Tom. We got I think we got 8 minutes left for questions. 7 minutes left for questions, Tom, and I'm just gonna keep asking them. Yeah, this is a question from Chris Schwarm. I'm not sure if you keep data on crowd volume, but do you see larger amounts of delay of game/neutral zone infractions in favor of the home team in stadiums that are like considered to be louder?
I would imagine. I think not. So we've done that analysis before. I believe the answer is yes. Don't quote me on that. I didn't necessarily do that analysis for this. But I definitely think that would be the case. I can double check that. But yeah, I mean, there definitely is an interaction between crowd noise and delay of game. I didn't measure it for this, however. And yeah.
Thank you. This is a question from Jeremiah Alago. I'm a little curious about the effect of weather on these games. Have you conducted? Do you have data on the difference of indoor or outdoor stadiums, or how severe weather conditions might benefit a team that is more used to them? So, like if you're a dome team and you go and travel and you go play at Lambeau in January, have you considered that kind of effect at all?
Yes, we have. We tried adding weather as an effect. We didn't do it too deeply. We just tried adding it. I think what maybe we added like condition or temperature. It wasn't that deep of an analysis. Part of it was we're not actually that interested in whether or not the weather. We don't care about the magnitude of weather. I mean, as a league, we can control rest, travel, home. We can control those sort of advantages. I have no control whether it's going to be snowy in Lambeau in January. That is not something I can do. So in a way, it's not even of our interest. But we did sort of briefly look into it just in case there was a really strong signal, and it's something we're not accounting for. But as I recall, we didn't find it strong enough to keep it in.
This is thank you, Tom. I think this is a really interesting question, and this shows this is one of the benefits of living in the world we're living in right now. This is a question from Amir, who is a master's student in data science from Israel. So we're all over the world right now, Tom. It's great.
Awesome.
It seems you used Bayesian inference. So my question is whether you have tried modeling rest and distance advantage for offense and defense separately. So they're asking about whether the rest could have different effects on offense and defense. It could be different effects for different units. And then they also say perhaps using the actual score line instead of the spread.
Yeah. So that last part of the question was sort of where I was going to go to start. Yeah. So since we are probability, and we actually use the money line to get it because that's a little bit more exact of a probability than a spread. But we're only using a probability. We don't actually know what did. We're not telling points scored by the home team, expected points allowed by the home team, vice versa. I definitely think that there's a chance that could be the case. It's a really good idea. But yeah, so definitely I could definitely see that being the case, and we'd probably have to maybe we use a combination of the spread and the over under. Maybe we just use the points scored. That definitely could have an effect, but that's not something we've looked into.
We're having there's a little bit of a meltdown happening down the hall right now with some children. But so here's another question. We have about 3 minutes left. This is from Nate Rowan. He says, "Thank you for the presentation." I agree with that, Tom. What is the approximate value of a single point in terms of implied win probability?
A single point, I think it's around maybe it's about 1%. Let me try to think. I know rest. Actually, it's probably more than that because remember rest advantage I think is about 1% and buy advantage is about 2%. So maybe 1 point would be about 3%, I think, although it's not a linear relationship. Yeah, I did have this in terms of percentages at one point, but I felt points was better, but maybe I could keep both for the future. And then home advantage is about 7 or 8%. So it's probably about 0.33 points is about 1%, but again, it's not a linear relationship, so it won't work out perfectly that way.
Right, yeah, because you're on the log odds you're on the log odds scale, right?
Yes,
right.
Exactly.
So it won't be. You can't just say that. Yeah. Okay.
Yeah,
it's linear in the log odds. All right.
Yes, it's linear in the log odds scale. That's true.
That's it. This is from Chrissy Sybil. Do you think the effect of bye weeks will be different this season since some teams are having their bye weeks moved? For example, I saw the Steelers kind of lost a day of their bye week because they were still practicing before they knew it was moved. That's an interesting question.
That's a really interesting question. I mean, we'll look into that after the season. Again, we don't have enough data on that quite yet, but that's definitely something that we'll look into after the season.
Okay. That is an interesting question because you're mentally prepared to have a bye week this week, and then all of a sudden it's your whole schedule, your whole season has changed.
No, yes. Some teams actually just take the week off, or a lot of the days of the week off during the bye week, and they were going into practice expecting to play. So
yeah, that's interesting. Fei Xing says, very interesting research. Any plan to apply your research in NFL and future NFL scheduling for even more balancing between home and away teams for even more competitive games?
Yeah, I mean, so our group doesn't do the schedule, but our group works with the scheduling team closely, and we give this information to them, and they do a great job. But it's a thankless job of making the NFL schedule, because there's networks, teams, leagues, like stadiums, all sort of wanting one thing and something else wanting another thing. But absolutely, we share this information with them, and they do with it what they want.
Thank you. Then Alexander Harriman said, "We do have a football team. It's been pretty good lately. Yeah, everyone gets it. Clemson wins football games. Great, congratulations." You. Okay. This is from Billy Fryer. Hi, my name is Billy Fryer. I'm an undergraduate at. How would you factor in games and holidays such as Thanksgiving and Christmas, or were these treated like normal Thursday games?
They were treated like normal Thursday games, and again, I hate to keep using the same answer. There's only 256 games a season, and not every season we even have Christmas games. I mean, we do have 3 Thanksgiving games every season. Maybe I can do something with that. But also another difficulty with that is two of the same teams play every year, and they typically play a division rival. So it's a recycling of teams that really play in those Thanksgiving windows. That's one problem with it. But yeah, we don't really have a big enough sample size. And again, we're not. I mean, maybe that would be of interest. Maybe if there's a disadvantage on playing on a holiday, that is something we'd have to take into account. But yeah, for now, we just treat it as normal Thursday games. I think you're muted, Greg.
Oh yes, I am muted because there's still a meltdown happening. With when you have 4-year-olds, there's meltdowns every 15 minutes. I've gone 1 minute over. June's furious with me. He's going to be so angry. We're 1 minute behind on the schedule, so I'm going to stop the questions there.
Okay.
And I'm going to say thank you, Tom. That was a great talk. Thank you for.
Thanks everyone for listening.
Yeah, and I'm gonna pass it back.